Hi, this is Mr. Max. I am, as you can see, from Namibia, and I'm doing graphs of the reciprocal function in typical y equals to some number over x, and we know that the denominator of a fraction cannot equal to 0. Right, so this content, again, as I said, is very useful for learners and those of you who are doing Cambridge and extended mathematics. I am going to get right into some practical examples that you can see maybe of what hyperbola around us in the world. Let's take this particular example when an aeroplane flies faster than the speed of sound, which is considered to be around 1,200 kilometers per hour, Mach 1. We say that it breaks the sound barrier. So when it does that, it sets up a shock wave in the shape of a cone, and you can see that when this sonic boom is formed, it hits every point on the curve at the same time. So that people in different places who are along the curve on the ground can all hear it at the same time. No sound is heard outside of the boom. So you can see that that parabolic or hyperbolic shapes that are formed by that sonic boom. Right, so I am going to talk briefly about the types of characteristics that you need to know whenever you're dealing with a discontinuous function like y equals to a over x, where a is bigger than 0. So if a is bigger than 0, this typically means that when you get graphs of the form, maybe y equals to, maybe some number, we can even say that number is 12 over x, or y equals to maybe 2 over x. As long as that is the case, then we expect your curves that you are going to draw to be in the first quadrant here, as well as in the third quadrant here. All right, this is how these particular curves would be. And when we are talking about an asymptote that is formed, we are referring to this particular graph that will never intersect with the y-axis, because the equation of the y-axis is the line x equals to 0. And we know that x cannot equal to 0 whenever you are dealing with fractions. All right, so your graph, whenever you plot it, it will never cut the y-axis. All right, it will form what we call an asymptote. Now this one here, if the value of a is negative, then the graphs are reflections of each other in the second as well as in the third, or in the fourth quarter rather. So these are typically graphs like y equals to maybe -3 over x, okay, or y equals to anything you can think of, -4 over x. Okay, excuse that line there. Right, so I brought a quick graph for you to see when you are given. Remember what I said, when the value of a is positive, we expect the answers to be in this first quadrant as well in this the third quadrant here. And as you can see, if you're given a table of values, then the only thing that you need to do then is just to complete the values. For example, so when you take x to equal -4 and you plug it into your function, you're going to get -1/2. And when you take x to be, for example, -3, you're going to get about -0.7, obviously to one decimal place. So whenever you choose the values of x here, the output values of y are what you get here. And what you then do is then you plug in these values as a coordinate point. For example, if I were to take just one random point, and I were to take, for example, this point here, all right? So that is the point 2, 1, all right? So it means then that if you were to plug that particular point in, this point here, on the Cartesian coordinate system, you will see that it's 2, 1. That point is going to be right there. And so you do for all the points. It will henceforth give you a parabola or a hyperbola that is in this first quadrant, as well as its reflection is going to be in the third quadrant. And that is the general characteristics that you need to know whenever you're dealing with such a graph. But I'm going to do about two of them, and I'm going to do it so that you can see how you are supposed to plot or complete a table and answer questions that are relating to the functions. And we can even bring other particular functions in there. All right, so this brings me to question 1. So we have here y equals to 120 over x, and as you can see, 120 over x is a positive value, the 120. So we expect our answers to be in the first and in the third quadrant or our particular graph. All right, remember it does continues. You are not going to let it cut the x-axis as well as the y-axis rather. So here they have particular missing points here. So when a is, or when x is 1, what is a? And when x is 5, what is b? So the way you solve that is you just plug in that value of x and then you get an output value for a, the same you do for b. And now you can actually complete your table. So when a or x is 1, a is 120, and when x is 5, y is 24. So now you've got your table complete. Normally you get a mark or 2 for that. Now you are ready to plot these particular points on the Cartesian coordinate system on your graph. So one thing also I need to bring out is when they are giving you the scale, like in this particular case, they are saying 2 centimeters should represent 1 unit on the x-axis, and 1 centimeter must represent 10 units on the y-axis. Now, what we know is your x values will be from 1 to 6, but it's very important for you to know what is the highest or the lowest value for y. So we know that our y is supposed to be 120, and since this is in the first quadrant, we do not really have a problem. So I expect a particular graph to look something like this, and I will be plotting all of these particular points. And when I do plot these particular points, I expect a type of graph that goes in this direction. Okay, because it's in the positive direction, it's in the first quadrant only that they are expecting us to answer the questions. All right, so this is what you need to know before you just start plotting your graphs. Right, let me bring then my particular graph. As you can see here, I have followed what I have said. So obviously here 1 centimeter on the y-axis represents 10 units, and I went all the way up to 130. All right, I know I was supposed to end at 120, but I like to go out by 1 so that there's enough space for me to do whatever I need to do on the graph. And then on the x-axis, they say 1 unit should equal to 2 centimeters. As you can see the scale, when the scale is all set up, you can actually now start with the whole graph. So I'm going to bring in my table. Right, so this is a table that I have, a completed table. So I'm now going to plot these particular points. The point 1, 120 is all the way up there. The point 1.5, 80 is all the way up here. The point 2 rather, 60, as you can see I have plotted it. And I bring up the point 3, 40. I bring up the point 4, 30, and the point 5, 24. So you need to be a little sure about your scale. Remember, here you have got 5 little squares in between 0 to 10. And when you have 5 little squares in between 0 to 10, you will realize that whenever you have that, you have got a little bit what? It's 10 divided by 5. So each little square just means then you're dealing with 2 units. So 24, for example, you get where your 20 is, and then you have 22, and then you have 24 like that. So you must make sure a bit that you do not make a mistake when it comes to plotting, and that you make sure that you have the right points. So the point 6, 20 is right down here. So now I've got all my points plotted. Remember, you should plot them all, and then I'm ready then to draw the graph. Okay, remember, as I said, this graph will never cut the y-axis. It gets closer and closer and closer as you go, and it forms what we know as an asymptote, but it will never actually cut that y-axis, and neither will it also, in this instance, cut the x-axis. Right, so I label my particular function whenever I'm done. Right, so the next question, let me just bring back my graph. So the next question, they are saying use your graph, and this is very important, and I've underlined it in red. You must find the value of x when y is 70. So you go to y is 70, You take your ruler and then you read down the x particular value, and it's an estimate, so it's more or less supposed to be x is equal to, or x is in the region 1.7. All right, so if you 1.6, 1.8, it will also be acceptable because it all depends on your curve, but it's basically 1.7. The next question, again, use your graph to solve this equation. You're not solving this equation algebraically. That's not what the question is saying. It's Roman 2. It's part of question C. The instruction here, use your graph, applies also to what you're supposed to do in this particular instance, right? So when we are asked to solve the equation, so you see on your right you have equals to 40. So you simply then draw the line y equals to 40, because that is the particular part that you have there. And now when you have drawn the line y equals to 40, you now only need to find where the line is intersecting with the function, and the particular answer is x equals to 3. And surely if you substitute 3 in here, 120 divided by 3 will give you 40. Right, so let me bring my grid back again for further questions, okay? So they are saying on the same grid here, now on the same grid that we have here, we're supposed to draw this graph, and this is y equals to 120 minus 20x for values of x between 0 and 6. And if you look at this function, it is a straight line function. So what I like to do for straight line function, since I know I only need 2 points, so I'll take the points where the line will intercept with the x-axis as well as the y-axis. So I will be choosing when x is 0 and when y is 0. So when you punch in x to be 0, for example, you get 120. All right, and you can see that point all the way up there in yellow as I indicate. And when I get y to be 0, x will be 6, or 6, 0. All right, and it's way down here. So now I have my 2 points, so I know it's a straight line, so I'm just going to therefore bring my line over. And what I'm going to do is I'm labeling my equations as always. Now, the next question here, they are asking you to write down the x coordinates of the points of intersection of the two graphs. So it is here where you can see this blue line is intersecting with the black curve here. This y equals to 120x is equal to 120 minus 20x, where they are equal to because they intersect. So you just have to give the x coordinate. Sometimes they do ask you to find the coordinate. Then you must give the x value as well as the y value. But here we are only interested in the x value. So the first one will be more or less about x is about 1.3. Okay, in that region. So you can go out by 1 decimal place. We normally take that little error there, 1.2 or 1.4. The next one here, where they intersect again, is about x equals to 4.7. So again, in the region of 4.6 all the way to 4.8 will be acceptable. Right, so F is about the same question, but they are only asking you here to write down an algebraic equation would have satisfied what we did in part E. Remember where the two functions are intersecting? You simply just say 120 over x, which is that curve, the hyperbola, equals to that straight line function. You're not supposed to solve it, all right? We already used the graph to solve it. We just want you to find how in algebra would you have done it. You would equate the two like that. Then the g part, remember I said this particular function here is a straight line function. They are only asking you for the gradient. So you can find this, you don't have to calculate the gradient here. All right, so what I like to do is I like to write this equation, just rearrange it and rewrite it in the form y equals to mx plus c. All right, or y equals mx plus b, depending which country you are from. But we tend to use the c for the y-intercept. Anyway, the gradient is the value of m, which you can basically just see from the equation, and it's negative 20. Right, so this brings me to my second question that I'm doing on this particular topic. All right, so here first, they like to start off like that. They give you a function and then you're supposed to complete the table. So we have got a p and a q missing here. Again, what you do is you then take when x is equal to -1 rather, and then you punch it into the function. And I like to put it in brackets like this, and if it's -1, sometimes it's a bracket, a minus outside. Could have been minus x squared. You need to remember that bracket, what goes in there has to be with its sign. All right, otherwise you may end up making problems. So we can see when x is -1, p gives us 0. And when x is 4 now, So when we get 4 and we sub in 4, we get the value of Q2 equals to 5, as you can see. So now that's about 2 marks because we've completed the table. So if everything is fine and you did not make a mistake with your points, you are ready to plot. Now if you remember from one of my previous videos, that is, here is a quadratic function. So this here is a parabola. And if you quickly do a little bit of revision, we expect this particular function to be a function that opens up here, and the reason is because the value of a is greater than 0. So what that simply means is whatever is in front of the square term here, it's positive. So we know that there is a 1 here, therefore we are going to have a graph that would look something like this whenever we sketch it, or whenever we draw it rather, or graph it. Right, so let me just continue then. So they are saying now, well, we have to, on a sheet of graph paper now, here's again, you must be a bit careful with your scale. They say on the x-axis, you must use 1 centimeter must represent 1 unit. And we know that you're going to do the x-axis from values of -3 to 5. And on the y value or the y-axis, you must use 1 centimeter to represent 2 units. You must be a bit careful. But how up or how down, how low and how high up should your y-axis be? All right. So for me to know that, I know that my x will be from -3 to 5, but the highest value comes from my table. When I look at my table, remember I can see the highest value of y is 12. So I expect to go all the way up to 12 when I draw my graph. And the lowest value I can see from my table is -4. All right, so I expect something in this particular form. So this, you need to have an understanding of how your graph will look like before you just start plotting or start drawing the x's and stuff like that. Have that idea and then take out your graph paper and then start plotting the correct scales, of course. All right, so I have done it here. So, and I've done it deliberately here so you can see by hand, so that you can see how the particular scale is supposed to behave. All right, so on the y-axis, 2 units represent 1 centimeter. The distance here is 1 centimeter, and on the x-axis, 1 centimeter is represented by 1 unit. Right, so I bring my table back because I'm supposed to remember the question wants us to plot or to draw this graph. So we have got all these points, completed points with the missing ones as well. So I'm just going to plot these particular points again. So the point -3, 12 is all the way here, -2, 5. You can see 5 is halfway between 6 and 4, so make sure you get that right, otherwise your point will be out. And -1, 0 is on the x-axis, as well as -3, or 0, -3 is on the y-axis, and then we get the point 1, -4 all the way down here, and then we have 2, -3. You see it turns back up, and then we have the point 3, 0. Okay, and then we have the point 4, 5, and lastly 5, 12. So now I have got all my points, and the way I plot them, I can already see they are behaving like what I said previously, like exactly that the function would be. So let me draw my curve, and also I label my particular function. Right, then they ask us a few questions, and I'm doing it here on this grid here. They're saying use your graph. Again, very important, you must use the graph to solve the equation. Now, the equation x squared minus 2x minus 3 equals to 0. Remember what is, if the equation is this, you're using graph, whatever is on the other side of 0, you actually write that stuff is y equals to that particular thing. All right, so here I have got a 0 here. So I'm looking then for the equation y equals to 0. Okay, and the equation y equals to 0 is nothing but solutions that are going to be where the graph intersect with the, you got it right, x-axis. Because if you know from, also again I said I've done a few things, that the equation of the x-axis is nothing but y equals to 0, and because that is the case, you're looking for solutions where the particular function is intersecting with the x-axis or the line y equals to 0. And when you can see from there, you can see that one of the values will be x is equal to -1, and another value here will be x equals to 3. Then they ask us another one here again. They are saying we're supposed to find solve by using the graph. Okay, solve the equation xy minus 2x minus 3 equals to -1. Again, I talked about this. You must then draw the line y equals to -1, and once you have this line, then you see where does this line intersect with the graph. So let me bring in that line here. You must be a bit careful. -1 is halfway between 0 and -2 there. All right, and now what you do is you are going to simply then find where does the two, or where does the line cut the function. What are the x values? Okay, because we're solving for x, we do not want the coordinates. All right, so one will be about here at -0.8. Okay, and the other one here will be at 2,8, as you can see there. So again, you are allowed to go out by one decimal place, but not by too much. Okay, so that is the particular solutions when you use your graph to these particular, where the functions are intersecting with one another. That is the curve intersecting with the straight line. Right, so let me bring my grid back here and my points as well as my particular function. Right, here now I have a table. Now they are saying we're supposed to complete the table of values totally for another function. All right, so I'm bringing in that particular table. So they have got values here of x, which is 0.25, which means we are supposed to plug it in here, get that output, and 2 here, we plug, we get the output. You can see already 2 divided by 2 will be 1 and so on. So we complete that. So when you do that, you will realize if you get 0.25, you get 8, and I talked about 2 already, and when you plug in 4, you get a half. Now we got those points. All right, it's a different function. We know what type of function it will be. Okay, it's a hyperbola, and it's going to be something here in the first quadrant again. Okay, and also maybe they are saying for values of x, so you probably will not need this particular values here, because if you look at the table, the values of x are only starting at 0.25, which is the positive direction. So we are not going to get the reflection of that in this other quadrant, because the values of x do not start from x, which is negative, but only from the positive part. So we are actually suspecting or expecting that grid, or that graph rather, to be in the first quadrant. So let me bring in the points, because they ask us to draw. So when you get 0.25 for the value of x, you get all the way up to 8. Again, make sure that you understand what does one small square represent. And remember, you have got 5 blocks between 0 to 1, and 1 divided by 5 gives 0.2. So 1 is 0.2, and the other one was 0.4. So 0.25 will be somewhere right here between these two little blocks here. Then when x is 0.5, you get 4, as you can see. When it's 1, you get 2. When x is 2, you get a 1. When x is 3, you get 0.7, so it gets very closer and closer to the x-axis. When x is 5, it gives you 0.4. So when you've plotted all those points, then you take your pencil with your free hand, and then you join, or you draw this particular graph by joining the points together. So I have done that there, and this is the solution to this particular question that wants me to draw this graph. Now, there is a E part which says write down the x coordinate or coordinates. All right, we can't give you hints like to say it will be a coordinate, then you expect only one answer, but coordinates. So when you drew, because I drew this particular graph here, I know that there will only be one point that they intersect. The x value will only be 1. So it's about there at 3,4, and that's how you answer this particular question. It's where they intersect. Okay. Right, this brings me to the end of this presentation. I am going to do power functions on the third video on my series of graphs, and after that I'm going to look at other type of graphs as well. Okay, exponential graphs and stuff like that. So don't forget to subscribe to my channel, and if you need to find out more exercises and also you need material, you can join my Google Classroom. The code for grade 11 is here, and the codes for grade 12 is here. So you will find a lot of material that you can use to your advantage.